Hello students, this is Dr. Siva Nagaraju from IARE. Today we are going to discuss definition terminology of module 4 in analog and digital communications course. Okay, so we know that definition, the meaning of the definition, and what is the terminology. So terminology is nothing but some technical terms or words that are used in this course, analog and digital communication course. Okay, now start the session. So the module 4, which is having digital modulation techniques. So this module 4 is covered by course outcome 4, and the course outcome 4 states that analyze the digital passband communication schemes using modulation and demodulation process. Okay, so this is module 4. Now coming to the definition terminology, what is a digital modulation? Before we know that modulation is nothing but it is a process of some of the characteristics of the carrier signal is varied in accordance with the instantaneous value of the message signal. So some of the characteristic. So some means here it may be amplitude, it may be time, it may be phase. So there is a normal definition of the modulation, but here we are in digital modulation. So the signals both are in discrete form. Okay. So now digital modulation is a modulation technique that uses discrete signals to modulate a carrier wave. That is, a variation in the parameter of the carrier wave is discrete. So already we know that how to convert an analog signal to digital one. Already seen that in module 3. So we are applying different operations like sampling, quantizing, encoding. Then we get the digital signal. Okay, so here the digital modulation is a modulation technique that uses discrete signals. So after applying sampling and quantizing, you are getting the discrete signal. So simply you can say that in analog form, that is a PAM, PWM, PPM, whereas in a digital you can say that a PCM and DM, ADM, like that. Okay, so these are the digital pulse modulations. Okay, so here we are using the discrete signals to modulate a carrier wave. So that is digital modulation. Now what is amplitude shift keying, or simply ASK? ASK. A binary information signal directly modulates the amplitude of an analog carrier. Here it is the modulation technique, not the conversion of analog digital signal. Why? Because why again you are converting this digital signal into analog carrier? Here the channel which accepts the analog only. So that's why here again we are going to convert this digital signal into analog carrier. So for example, here we can say this is 101 digital signal. By using ASK, here like that, like that. Here the carrier is going to variation in between symbol 1 and symbol 0. Okay, this is ASK, amplitude shift keying. So the binary signal when ASK modulated gives a 0 value for low input, while it gives the carrier output for high input. Okay, so in this way ASK is going to modulate symbol 1 and symbol 0, amplitude shift keying. Here only the amplitude is shifting. Coming to what is on-off keying, in simple you can say OOK. In amplitude shift keying, as information signal is binary, only two input voltages +1 or -1 occurs. As a result, we get only two output voltages, AC cos omega CT or 0 volts. Because of this carrier is either on or off state. So that is why ASK is known as on-off keying. Already seen that in the previous slide. For symbol 1, we are giving the carrier. For symbol 0, there is no carrier. So here you can say on-off, just like a switch. Switch is on when the bulb is glow. Switch is off, the bulb is off. Like that, this ASK is working as a on-off key. So another name, ASK you can call as on-off keying also. Now what is a frequency shift keying? A binary information signal directly modulates the frequency of an analog carrier. Here, a binary information signal directly modulates the frequency of an analog carrier. Here the frequency is shifting. So we can see, for example, this is the digital signal like that. So this is 1, 0, 1. Here the FSK gives two different frequencies for symbol 1 and symbol 0. For example, like that. Okay. Like that. Like that. So here we can say for symbol 1 having one frequency and symbol 0 having another frequency. Two different frequencies are using for representing symbol 1 and symbol 0 in FSK. Okay, so here the binary information signal directly modulates the frequency of an analog carrier. Here the below one is the carrier signal. How the FSK shifts from 1 to 0. Here I am showing symbol 1 having a low frequency signal and symbol 0 is a high frequency signal. It may be vice versa. In some one symbol 1 is showing as high frequency signal and symbol 0 may be shown as a low frequency signal. What it may be. But what is our motto? Here two different frequencies. That is FSK. And another one is the PSK. What is a phase shift keying? A binary information signal directly modulates the phase of an analog carrier. Here also, for example, 1, 0 and this one also 1. So here I am giving here two different phases, or in previous like we can show full signal, full signal, full signal, no problem. So here we can see symbol 1 having one phase, symbol 0 having another phase. Okay, so the phase shift between symbol 0 and symbol 1 is 180 degrees. Just pi. Pi is 180 degrees. So 180 degrees phase shift is given to the PSK. Okay. What is binary modulation? In binary signaling, the modulator produces one of two distinct signals in response to one bit of source data at a time. Here, two types of modulations are. One is a binary and another is a M-array. Here, only one bit we can send at a time. That is binary modulation. We can modulate one bit at a time. Here, what are the two distinct signals? Here, that is 1, 0. So, I can send at a time either 1 or 0, not both. Okay, so that is the binary. What is binary phase shift keying? Here, binary phase shift keying or BPSK is a two-phase modulation scheme where the zeros and ones in a binary message are represented by two different phase states in the carrier signal. Theta is 0 for binary 1 and theta is 1 degrees for binary 0. So here we are having only two signals, that is 1 and 0. So here 0 degrees for symbol 1 and 180 degrees for symbol 0. So as usual, we've seen that the previous how that signals are opposite phase. So in another sense, you can say these two signals can be called as antipodal signals. They are in the same plane but in opposite phases. That can be called as antipodal. The amplitude is same, but what are the difference? Phase is opposite. Phase is 180 degrees phase shift, reverse. So that is binary phase shift keying. And another is what is quadrature phase shift keying? QPSK. So QPSK is a form of phase shift keying in which two bits are modulated once, selecting one of four possible carrier phase shifts. That is 0 degrees, 90 degrees, 180 degrees or 270 degrees. Okay. So here we can select any one of this phase shift, either 0, 90, 180 or 270 degrees. And here it can be sent 2 bits at a time. It can send 2 bits. Why for QPSK? Here, in any communication system, we must save the power and at the same time bandwidth. When I am using binary signalings, that is ASK, PSK, FSK, they are using more bandwidths. Why? We can send only 1 bit at a time. So the same bandwidth, it can send only 1 bit. So we are losing some bandwidth. So the bandwidth utilization, we move for QPSK. So QPSK can send 2 bits at a time. That can be called as D bit. It is in form of gray codes. Okay. So QPSK is the advanced one and more using modulation technique. What is 8PSK modulator? So 8PSK modulation or multi-level PSK modulation is a type of digital modulation based on carrier phase change in which 8 different phases or 8 different phase angles are used to represent bits. Whereas previously we seen 4 phases, that is QPSK. Now it is 8 PSK. So 8 different phases are can use it. Okay, so this is 8 PSK modulation or modulator. And another is what is differential phase shift keying, DPSK. So in DPSK, the phase of the modulated signal is shifted relative to high or low state of the previous signal element. So this DPSK technique doesn't need a reference oscillator at the receiver. And another thing, we can view this DPSK as the non-coherent version of PSK. Okay, non-coherent of PSK. Already we know that what is coherent, what is non-coherent. So these coherent action and non-coherent actions are come at the receiver. Okay. So generally DPSK can be viewed as a non-coherent version of PSK. So here they didn't require any reference oscillator at the receiver. So in this sense, it can be called as non-coherent version. So what is coherent version? In coherent, we must require the a reference signal, a reference phase at the detection of the original signal. Okay. Now it doesn't require any reference oscillator at the receiver for detection of the message signal. Okay. What is mark frequency? In FSK or in frequency shift keying, the carrier wave modulates itself to a frequency known as mark frequency when the input logic is 1. Okay, so this mark frequency come at FSK. Come in FSK. Another is space frequency. So this also related to the FSK. So in FSK, the carrier wave modulates itself to a frequency known as space frequency when the input logic is 0. Why? Because here we are having only 1 and 0. Already I said for symbol 1 have a different frequency and symbol 0 having different frequency. So when the frequency at symbol 0, it is space frequency. When the frequency at symbol 1, it is mark frequency. Okay, so the names are given. Now what is a coherent detection? Coherent detection requires a replica carrier wave of the same frequency and the phase at the receiver. The received signal and replica carrier are cross-correlated using information contained in their amplitudes and phases. It is known as synchronous detection. So coherent detection means it requires a replica. I require a reference signal. Without that reference, we can't detect the signal at the receiver. Okay. What is non-coherent? Non-coherent detection doesn't require a reference wave and it does not exploit phase information. It is less complex than coherent detection but has poor performance. When you compare with the performance levels, coherent is the best one, but non-coherent performs very poor. Okay, but what is the advantage? It is less complex than the coherent detection. So depend on the application, we go for the either coherent or non-coherent version. What is a synchronous demodulation? The clock frequency at the transmitter, when matches with the clock frequency at the receiver, is known as synchronous method, as the frequency gets synchronized. Okay. So here in a coherent detection, we may use the replica of phase or the replica of the frequency. Okay. So we are using frequency, it can be called as synchronous detection, synchronous demodulation. Okay. So what is a asynchronous demodulation? When the clock frequency at the transmitter doesn't matches with the clock frequency at the receiver, it is known as asynchronous. If the frequency matches both at the transmitter and receiver, we can call it as synchronous. It doesn't matches, we can call it as asynchronous. Okay. What is IARE ASK? Or what is IARE? So IARE ASK or IARE PAM, the amplitude of the carrier takes on m different levels. So here m is equal to 2 power n, simply you can say. What is n? Number of bits. Number of bits. So I can send 1 bit at a time. For example, I can send 1 bit at a time. What happens to my m value? M value is 2. Sorry. Here 2 power 1 is 2. So it can be called as binary. When m value is 2, it can be called as binary modulation. So we can send 1 bit at a time, either 1 or 0. For example, n equal to 2, I can send 2 bits. What is my m value? 2 square, 4 bits. So what is the example of this 4? Is nothing but QPSK. For n equal to 2, it may be ASK, PSK or FSK. So when n value increases, that IARE technique. So for example, m equal to 2 power 3, that is 8. So the meaning is here 3 bits we can send at a time. IARE modulation. So already you know that we are having 2 varieties of modulations, binary modulation, IARE modulation. So here in binary, it takes only one bit. But here in IARE, the amplitude of the carrier signal takes on m different values. For example, here 8 PSK. So 8 different phases are considered. 8 different phases are considered. So that is 8 PSK. But generally, normal or ordinary binary PSK, how many values? Only 2. That is 0 or 180 degrees. 0, 180 degrees. That is for ordinary BPSK. When you move for IARE, it takes m different levels. Okay. Coming to IARE FSK. Here, IARE FSK, the frequency of the carrier signal takes on m different values. Here, the frequency takes different m levels. So here also same, m equal to 2 power n. So what is my n? How many bits are you sending? Depends on that modulation. Okay. So FSK means here for binary BSQ, binary FSQ considered, for symbol 1 and symbol 0, we are sending different frequencies. What is different frequency? The carrier. The carrier producing different frequencies for symbol 1 and symbol 0. At the same time, for IARE, it takes m different frequencies, m different values of frequencies. Okay. So that is IARE FSK. Again, what is IARE PSK? Similarly, IARE PSK is also the phase of the carrier takes on m different levels. If it is ASK, the amplitude of the carrier takes m different levels. If it is FSK, the frequency of the carrier takes on m different levels. If it is PSK, the phase of the carrier takes on m different levels. Okay. What is antipodal signals? Antipodal signal or signal with 180 degrees opposite to each other. One signal has a value of -1 and other has +1. So it is an example of BPSK. This is 1 and this is -1. This is for symbol 1. This is for symbol 0. Okay. So when you see this such type of figure, this is a signal space diagram. Signal space diagram, we can see such type of arrangements. So this is for PSK. So the PSK signals can be called as antipodal signals or BPSK, binary phase shift keying. Okay. So when you apply for the bit energy, that is root EB. So one having root EB, another is minus root EB. But the value is +1, -1. For symbol 1 having +1, for symbol 0 having -1. What is the probability of error of or bit error rate? Probability of error or bit error rate. So BR, bit error rate, is an empirical record of a system's actual bit error performance. So in digital communications, we are calculate the performance of the system by BER. Whereas in analog communication, we are judge the performance of the system by SNR, signal to noise ratio. But here we are taking the bit error rate. What is BARD? BARD refers to the rate of change of a signal on the transmission medium after encoding. After encoding means, so this is purely related to the digital one. Why? In analog there is no encoding. Analog communication there is no encoding. Only encoding is there in digital communication. So BARD refers to the rate of change of a signal on the transmission medium after encoding. What is matched filter? The matched filter is the optimum linear filter for maximizing the SNR in the presence of additive stochastic noise. So here we are using either correlation filter or matched filter for detection of the signal in presence of noise. So we are going to maximizing SNR in the presence of additive white Gaussian noise or additive stochastic noise. Okay. So matched filter is the optimum linear filter. Second one, outline line encoding formats. Outline line encoding formats. So digital coding is a special coding system used to represent binary digits on a transmission medium. Line encoding takes place at the physical layer of the OSI model. Here different formats like NRZ, BRZ, Manchester. So different or on-off line coding. So it is an electrical representation in transmission medium. Okay. So digital line coding is a special coding system used to represent binary digits on a transmission medium. Here don't confuse this coding to error control coding. Why? Because here encoding are different types of there. That is source encoding, channel coding. Okay. And last one is error control coding. Outline unipolar encoding. Unipolar encoding is a very basic method of encoding which makes use of one polarity, that positive voltage, to represent a binary 1, and it uses an ideal line to represent a binary 0, that is 0 voltage. Here only one polarity, unipolarity. That means it gives only polarity for 1 and 0. It is ideal. Like this. Like this. This is unipolar coding. Only one polarity. What is polar encoding? Polar encoding represents bits by using two levels of polarity or amplitude, positive and negative. Positive and negative polarity. What is now written to 0 encoding? These are the encoding formats or line coding formats. NRZ encodes a signal that is always positive or negative but never 0. If the line is ideal, that is neither positive nor negative, then there is no transmission. Here there is no 0, non-written to 0, that is the meaning. Either positive or negative. For example, for symbol 1, it gives positive. For symbol 0, negative. So there is no chance of 0 level. For example, this is 0 level. Here 1, 0, 1 is coming. So what I am doing? Like that. Understand? So positive, negative, positive polarities. So it doesn't touches the 0 level. What is correlation receiver? Correlation receivers are used to reduce the effect of interference in the gain and other parameters of the system. So these are the two receivers, match filter receiver, correlation receivers. Okay. Outline biphase encoding. Biphase encoding is a variation on polar encoding. It works by changing the signal in the middle of the bit interval, and however the signal doesn't return to zero, it continues to the opposite pole. It does not return to zero. Okay. What is Manchester encoding? Manchester encoding uses inversion at the middle of each bit interval for both synchronization and bit representation. A negative to positive transition represents binary 1, whereas a positive negative transition represents for binary 0. Okay, positive to negative, negative to positive. So for symbol 1, this is negative to positive transition, like this. For 0, like this. Okay. What is bipolar encoding? Bipolarity. So bipolar encoding utilizes 3 voltage levels: positive, negative, and neutral. 0 is used to represent binary 0, and binary 1 is represented by alternating positive and negative voltages. That means for one time you go for positive and another one is come, you go for the negative voltage. Symbol 0 represents always 0. So for example, this is 101. So what to do for this one? You can see this is positive and this is negative. Bipolar, two polarities. For which symbol? Symbol 1. For symbol 1, we are providing 2 polarities. For symbol 0, there is no signal. Simply it is 0. What is alternate mark inversion? Simply AMI. So alternate mark inversion is a bipolar encoding system where neutral voltage or 0 voltage represents binary 0 and alternating positive and negative voltage represents binary 1, which is similar to bipolar. Okay. In binary data transmission, DPSK is preferred to PSK. Why? Because. So DPSK is a non-coherent version of PSK. It is differentially coherent modulation method. DPSK doesn't need synchronous carrier at the demodulator. And another one is the input sequence of binary bits is modified such that the next bit depends upon the previous bit. So these are the features of DPSK than the PSK. So that's why we are using. List applications of QPSK. QPSK allows the signal to carry twice as much information as ordinary PSK using the same bandwidth. Already discussed. Using the same bandwidth. QPSK is used for satellite transmission of MPEG-2, video, cable modems, video conferencing, cellular phone systems, and other forms of digital communication over an RF carrier. So these are the applications of QPSK. So more frequently used digital modeling technique is QPSK. List applications of BPSK or PSK. PSK technique is widely used for wireless LANs, biometric, contactless operations, along with RFID and Bluetooth communications. So these are the different applications of BPSK. So already covered different this coherent detection. Now define intersymbol interference. Intersymbol interference is a form of distortion of a signal in which one symbol interferes with the subsequent symbols. This is an unwanted phenomena as the previous symbols have a similar effect as noise, thus making the communication route less reliable. So we can call this is ISI, inter-symbol interference. This is a symbol which is going to interferes with the subsequent symbols. This is inter-symbol interference. Define eye diagram. An eye pattern, also known as an eye diagram, is an oscilloscope display in which the digital signal from a receiver is repetitively sampled and applied to the vertical input y-axis, while the data rate is used to trigger the horizontal sweep. So this is an oscilloscope display. Oscilloscope display. Eye diagram is an oscilloscope display. Okay. Define quadrature amplitude modulation. Quadrature amplitude modulation can be defined as a modulation technique that can be used to combine two amplitude modulated waves into a single channel to increase the channel bandwidth. References. So development of this content or the content of information is taken from Communication Systems by Saman Hakim, Jas Chitori, and Sanjay Sharma. So these books are referred for development of content of this information. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.